So again, I'm saying on the for the video also. So thank you to you guys for coming, and no thanks to you watching on YouTube for not coming. But whatever, do what you want with your life. All right. Anyway, thanks again. Yeah, thank you. Thanks for enduring the rain and being here. Today I'm going to wrap up chapter 3. We'll talk about box plots, and then we'll get into start chapter 4. Okay. So next week on Tuesday you'll have a quiz that will cover chapter 3 stuff. Okay. I'm sorry, chapters 1 through 3. So your quiz will be on Tuesday, covering stuff from chapters 1 through 3, and then and that should be good. Okay. And then the following week you'll have your first midterm exam, which covers stuff also. And we'll talk about that when we get there. So don't worry about that. Okay. So, and then and please make sure you acquire your clickers and have them registered. We'll start using them third week Monday. Okay. And the point of the clickers is to make it interactive and for me to kind of post some challenging questions that get you guys to think and use that as kind of a point to discuss some of the finer points of topics being covered. I do ask, and this is a personal favor, I do ask that you don't bring in more than one clicker and click in answers for your friends who decided not to come. Okay, so just, I mean, technically that could be considered academic dishonesty. Just bring your own clicker and click for yourself. So I just ask that you don't do the clickers for other people as well. Okay, so let's wrap up chapter 3. We're going to talk about box plots. Okay, so box plots. This is a graphic display.
Can you make it darker?
Oh yeah, I always forget. Thank you for the reminder. Okay, so box plots, these are graphic displays for numeric data. What are the other displays for numeric data include what? Yeah, So other data displays for numeric data include histograms. What else? Histograms, dot plots, and one more? Stem plots. Okay, so these are the ones we've covered. So after today, you'll also have box plots in there. Okay, and so this is what a box plot looks like. Okay, and then maybe you'll have an outlier down here or something. I don't know. Okay. Actually, let's get rid of this thing. Okay, so the box is defined by 3 lines. You have Q1, the median, and Q3. Okay, so that means, what is the width of the box? The width of the box is the IQR, okay, because the IQR is the distance from Q1 to Q3, so the width of the box is the IQR. So just by looking at the width of the box, we get a sense of the spread, and also by basically looking at kind of the whiskers and the outliers, we also get a sense of the range as well. Okay. All right. Well, what separates the outliers from the rest of the data? Well, we set up these invisible boundaries, okay? So what we're going to do is we're going to take this width of the box and we're going to multiply it by 1.5, okay? So we're going to say, all right, here is one width of the box, okay? And then here's another half, okay? So this is going to be, this distance is 1.5 times the IQR, or basically 1.5 box widths, all right? And this sets up an invisible line known as the upper fence. Okay, and we would do the same thing in the opposite direction. I don't know if I have, so, you know, this is one box width and then another half box width. Okay, and maybe this is not to scale. So this down here would be, again, 1.5 times the IQR. And this would be the lower fence. Okay? So any data points outside of the fences are considered outliers. Well, I should say potential outliers, but for most intents and purposes, they can be considered outliers. Okay. All right, the whiskers. So this would be our whisker, and this would be a whisker down here. The whisker goes to the largest data point or the smallest data point that is not considered an outlier. Okay. Some texts will say the whisker goes to the fence. I would say that's a less common thing. The whisker usually ends at the largest data point or smallest data point that's not considered an outlier. Okay, so the whisker doesn't necessarily go up to the fence. Are there questions on this? I'll let you guys give you a second to write all of this down. So yeah, so these things out here would be considered outliers, as would this data point out here. Okay, so the formula for the upper fence and the lower fence would be what? Q3 plus 1.5 times the IQR. And then the lower fence, what is the lower fence? Q1 minus 1.5 times the IQR. Okay, and so looking at a box plot, this is kind of like our a bare bones graphic display of the data. Okay, so we can think of as a box plot as a quote unquote bare bones display of the data. However, it still captures a lot of information, okay? So even from a box plot, you still, a box plot will still reveal skew. Okay, but it will not reveal whether it's unimodal or bimodal, okay? Okay, but you know, if you have a box that looks like this, okay, from here, from this picture, we can tell that this is what? This is right skewed, right? So if we look at, so this is, what we see, you know, here's the median, and we can see we have, you know, extreme values in this direction, right? So we have extreme values over here. Even without the outliers, it would be right skewed because just our extreme values are way up high. But you know, if you look at the left side, you know, no extreme values on the left side. Okay, so just from looking at the box plot, we can get a sense of whether it is right skewed or left skewed. I'm sorry, I'm looking out at the class, and some of you look like you've seen better days. Okay, I don't mean to laugh. I apologize. All right, is this okay? All right. Oh, okay. All right. Thank you. Now I'm seeing smiles and whatnot. Okay. And you know, we can also make quick comparisons with box plots. Quick comparisons between groups of data. Okay, so for example, I could draw, you know, one box plot that looks like this. Okay. And actually, this would probably only, because you can only go out 1.5, right? So we'll just have a couple of outliers out here. All right, and so, you know, if this is group 1 and this is group 2, what can we say about comparing the lower ends of group 1 and group 2? What do we say? We'd say both group 1 and group 2, both group 1, group 2, you know, have about the same minimum value. Okay, because, you know, our minimum is down here and down here, right? This is where our minimum is, and it looks like they're about the same minimum value, and it looks like Q1 is the same. Okay, can we see that from our box plots here? Okay, same minimum, same Q1. Okay. However, if we look at the median, we see the median of group 2 is higher than the median of group 1. Okay. So when we're talking about central tendency, we can say the center of group 2 is higher, is okay. And in fact, it looks like the median of group 2 is equal to about Q3 of group 1, right? Okay. And as far as group 1 goes, its maximum value is an outlier, but its max value is still less than the max value of group 2, which is out here, okay? So max value of group 1 is an outlier, but is still less max value of group 2. Okay, and so just from a few simple lines and dots, we can kind of summarize a fair amount of data here. Okay, it's also interesting to note that anything beyond over here, this encompasses 25% of the data. From here to here encompasses 25% of the data, because this is what the median in Q3. From here to here is 25%. Okay, and then anything lower than over here would also be 25%. Okay. And you can draw similar lines for the upper box plot as well. Okay. Is this good with everybody? Okay. All right. So that wraps up chapter 3 then, and we'll start chapter 4. Okay. So chapter 4, we're still in this section of descriptive statistics, but in chapter 4 we are covering describing a relationship between two numeric variables. Okay. So chapter 3 was all about basically describing a numeric variable, its distribution, its center, its spread, its shape, all of that. Numeric summaries and graphic displays. Chapter 4, we are describing now two numeric variables. Okay. And so, I'll start off with kind of a silly example here. So just imagine we're looking at a certain species of snake, okay? I hope we don't have too many snake haters. Okay, so we're going to look at a certain species of snake, and we want to know, is there a relationship between the length of a snake and its weight? Okay, so we'll have two numeric variables. Our two variables are length of snake, and we will call this X, and we will have weight of snake, and we will call that Y. Okay, so so here I'm gonna draw this is my snake. Okay, so here's one snake. This requires great focus, so be quiet. Yes, okay. All right, success. All right, so here I've got two snakes, and if we had to guess, which one would you guess weighs more? The longer one, right? Okay, so we would guess this snake all right. This is a all right, I don't know why I'm so excited about my snake drawing here. Okay, so then we'll pretend like we went around and we gathered snake measurements. So we have the length of a snake and the weight. I always think of Harry Potter and never mind, Slytherin. All right, so let's say we have a snake that's, I don't know, 12 inches long, and a snake that's 14 inches, and I don't know, 10 inches, and 8 inches, okay? And then the weight, oh, this is hard, I don't know. 14 and 16 and 10 and 9. Okay, and then so we're going to graph this. And this display is called a scatter plot. And you just create, kind of coordinate pairs here. So along the X we will have length, and along the Y we will have weight. Okay, so what do I have? So I'll start off at 7, 8, 9, 10, 11, 12, 13, 14, 15, okay, and then 8, 9, 10, 11, 12, 13, 14, 15, 16, okay. All right, so I'm going to draw each of these. I've got 12 and, 11, 12, 13, 14, 15. Okay, so 14 and 12, I think that gets a dot right there. 14 and 16 gets a dot right there. And then 10 and 10 gets a dot right here, and 8 and 9 gets a dot right here. Okay. So here is my scatter plot, and if we had to characterize kind of an overall trend, we would say it appears that longer snakes tend to weigh more than shorter snakes, right? And that makes sense, right? Anyone excited for what is it? Magical beasts and where to find them? Okay, all right. At least I got one smile there. What is that? It's a it's a movie that takes place in the Harry Potter universe with never mind. Eddie Redmayne. He's oh, what is this? Salazar, the, yeah, whatever, okay. The guy who writes the Magical Beasts book that is featured prominently in book 3. All right, so we have, so when describing a relationship between two numeric variables, we should mention, I don't know why I put that over there, two numeric variables, we should mention, okay, the direction or trend, okay, and that can be described as positive, negative, or neither positive nor negative. Okay, we should mention the strength of the relationship. So we'll have terms like strong or weak, moderate. Okay, and then the shape of the relationship. Okay, and as far as this class goes, we will either have linear or nonlinear. Okay. Okay, so I'm going to flip. All right, so let's talk about each of these. So we'll talk about the direction or the trend. All right, so if a relationship is positive, so we have positive direction, that generally means large X tends to be associated with large values of Y. So large X values tend to be associated with large Y values, okay? And small x goes with small y. Okay. Again, this is just an overall trend. Okay, so yes, you could have, quote, unusual data points where you have a large X and a relatively small Y or things like that. But overall, the trend is large X goes with large Y, small x goes with small y. Okay, and so the graph for a positive relationship would look something like this. Okay, and so if we look at, if this is our x and this is our y, we look at over here, I've got large X, and we look at where that goes up here, and it's on the high end. This goes with large Y, and down here, small x tend to go with small y. For the negative, it's just the opposite, okay? Large X goes with small y, Okay, and small x goes with large y. All right? So we would have something like this with x and y and, you know, large x here. This goes with small y, right? These data points out here, okay? And over here, small x goes with large y. All right, so examples of the positive direction are snake length and weight is an example of positive. So snake length and snake weight would be positive. An example of a negative relationship could be vehicle mileage and resale value. Okay, so vehicles with high mileage tend to have lower resale values, or if you're trying to sell your used car, the car that has 200,000 miles on it probably will not sell as much as the car with 20,000 miles on it, right? So small x goes with larger y, big X goes with smaller y, okay? And of course there could be outliers, and there's a lot of things that determine a car's resale value. So, if you're selling a Honda Civic versus a Mercedes-Benz, the mileage will play a factor into it, but there's other things at play too, okay? All right. And then we have neither positive nor negative, okay? Okay, so you could have something like something like this, okay? This could be neither positive nor negative. This could be like a, I don't know, number of pizza slices you ate. This will be our X versus hours of sleep you got in the week. Okay, so, you might have certain weeks where you ate lots of pizza, but you probably got about the same number of hours of sleep as the weeks where you didn't eat much pizza. So, okay, I don't know why that's the example, but that's the example, all right? So, number of hours of sleep you get in the week probably will be fairly steady, right? I mean, some weeks you're not going to get that much sleep, but I don't know. I don't know if there's going to be a trend relationship that depends on how much pizza you eat. I don't know, unless you have like some strange habit of only eating pizza during finals week or something. I don't know. Okay, you could also have a cloud of points that look like this, where you have neither a positive nor a negative relationship. Okay, so this could be something like SAT score and shoe size. Okay, so you're going to have students or people with high SAT scores with big feet and little feet, people with low SAT scores with big feet and little feet. There's not going to really be a positive nor a negative trend there. Okay, or you can have something that looks like this. This could be X could be, time after liftoff. And Y could be altitude of your toy rocket. It could look something like that. All right? And so these would be neither positive nor negative. Okay? However, it is important to note that if we were looking at this, this example and we were to stop recording data right here, okay, based on this data, the overall trend is a positive relationship. Okay? So if we stopped recording the data here, based on this data, there's an overall positive relationship. Okay. Hang in there. So far, so good? All right. Any exciting plans for the weekend? Huh? Retreat? No. All right. And then, okay, we'll talk about the strength of a relationship. Okay, so the strength of a relationship, we can think of this, one way to look at it is, can you make good predictions for one variable based on the other variable? Or, just another way is like, how much scatter do you see in the scatter plot? Okay, so here I'll show you two positive relationships, and this one something like this. Okay, this would be a strong relationship. Okay, if you have some value x here, can you make predictions for y? Okay, your predictions for y would be in this kind of small range here. Okay, so given a value of x, you can make a fairly good prediction for y. Okay, we also see low scatter, right? And then over here, okay, so overall there's still a positive relationship, but we have more scatter, lots of scatter. So here we would have a weaker relationship. Okay, and then if I give you a particular value of x, if x is right here, what are plausible values for y? The range of values for y is kind of this much wider thing, right? So given an x, given a particular x, okay, there is still a fairly wide range of possible y's. So that would be a weaker relationship. I see my lecture has put some of you to sleep. That's okay. All right, let's, I will not be discouraged. Okay, so let me just give you a few examples. Okay, so we have, let's say for x, we will measure height, a person's height in inches. And y will be the same person, the person's height in centimeters, okay? So this will have actually a perfectly strong relationship. Okay, because if we think about it, there's going to be no scatter here. If you know the person's x value, we can figure out the y value perfectly, okay? So if we know x, we can predict y precisely. All right. Okay. Another example, we could have x would be a person's height, however you want to measure it, okay? And the y could be the person's arm span. Okay? So they're, based on your height and how wide your arms are, there's a very strong relationship, okay? Most people have something very close to a one-to-one relationship between height and arm span. You've probably seen that Leonardo da Vinci picture with the guy in the circle. Yeah, the Vitruvian Man, I think. But it's not going to be perfect. Okay, not everybody's arm span is exactly their height. Some people will be plus or minus just an inch or two. But overall, there's going to be a very strong relationship. Okay. So here we will have a strong relationship, okay, a little bit of scatter, okay, so two people with the same height can have slightly different arm spans. And I guess this data set assumes people without disabilities or congenital problems. And then lastly, we could have a person's height and y would be the person's weight. Okay, and so here there's still overall a positive relationship. In general, we expect people who are tall to weigh more than people who are short, but as far as how well can you predict someone's weight if you only know this person's height information, your predictions will probably not be as good because there's a lot more variation in people's weight. Okay, so if you have two people with the same height, they can vary quite drastically in terms of weight. So here we will have a weaker relationship. Okay, so, more scatter. Two people with the same height. Can have, very different weights. All right. Okay, and then so lastly, with our last minute, do you guys have this written down? Okay. It's very easy. We just have linear versus nonlinear. Okay? So linear means a straight line can summarize the relationship and nonlinear, a straight line does not work. Okay, so linear, anything. So this would be linear. And then anything that's, nonlinear, okay? So anything that doesn't fit a straight line, we would just say nonlinear. Okay, that's it. Have a great weekend, and we will see you guys on Monday.